Now let's first review some of the materials that we discussed in the last week. Okay, uh, we talked about two types of data: categorical and numerical. Okay, categorical and numerical. Okay, so categorical is divided into nominal and ordinal. Neither of these two categories, neither nominal nor ordinal, has a numerical value. So it makes no sense to do arithmetic on these two type of data. We can just count or take the percentage of the values for these two type of categories. Okay, so nominal is just a label. We label our data. We can label it with alphabets, or we use numerical labels like 0 and 1. But as I said, we cannot perform any mathematical calculation on either of these two categories. So with nominal, which is just a label, for ordinal, we can define some orders between the values or categories of our variable. For example, in a survey, we ask our customers whether they're satisfied with the product or service that they receive. Okay, so for our variable, for example, variable A, we define three levels: very satisfied, satisfied, or dissatisfied. Okay, so we have three categories or three levels for variable A. Okay, so the difference between this ordinal variable and the labels is that there is some ordering between these values. We know that very satisfied is much better than satisfied. Dissatisfied is worse than satisfied. But the problem is that we cannot measure the difference between these values. We don't know if the difference between very satisfied and satisfied is the same as difference between satisfied or dissatisfied. So we know nothing about this ordering. We just know there is kind of order between these variables. We classified our numbers into two categories in the last week. We divide them into discrete, like binary values, 0 and 1. Okay. And we also define the continuous values. Okay, this is one classification regarding the numerical variable. In other classification, we can define categories like interval, and ratio. Okay, so these are the categories that can be defined within numerical variables. Interval data, they have all the characteristics of the nominal variable. We can define the ordering between variables, and we can also, the other point is that in interval we can measure the difference. For example, today, Monday, is 10 degrees of Celsius or 10 degrees of Fahrenheit. Okay. Thursday, the temperature is predicted to become 20 degrees of Fahrenheit. Okay. We have two numbers and there are some orders. We know that 20 Fahrenheit is bigger than 10 degrees of Fahrenheit, but one advantage of this variable over categorical nominal variable is that we can measure the difference. We know that the difference between temperature now is 20 minus 10 equals 10 degrees of Fahrenheit is the difference between these two temperatures. Okay. But what is missing here is that we don't have true 0 point, no zero value, no 0 point. This is the main drawback of this data type. For example, when we say today is 0 degrees of Fahrenheit, it does not mean we have no temperature. Okay, so because of this weakness, we cannot perform multiplication or division on this type of data. No multiplication or division. So it makes no sense to multiply this kind of data interval. So we cannot calculate the ratio between variables. In order to do that, we need to use the ratio variable. Ratio, we can do all type of mathematical calculation like summation, subtraction, multiplication, division, like your weight or height. Zero height means it has no height, or so we have 0 point here in this variable. Does that make sense so far? Please give me feedback. All right, so we provided a new classification for the numerical variable. You became familiar with discrete and continuous, and now we know that we have interval, category within numerical variable, as well as ratio. Okay, so now we want to see how we can report or summarize our data in a way that makes sense to the end user. Suppose this data set, supermarket sales, contains data or transaction made by customers at a kind of hypothetical supermarket. So here you see different variables. Transaction is a kind of label. Purchase date is a date. Customer ID, again, it is a label. Gender, male or female, is a nominal. Marital status, we have again a nominal. Homeowner, yes or no, nominal. Number of children, it is a numerical and ratio. Annual income, again, it is a categorical variable. City is a label or nominal. State, nominal. Country, nominal. Units sold, numerical, and revenue. So we have only 3 numerical variables: revenue, units sold, and number of children. The rest are categorical. So now we want to see how we can report the categorical variable. Like gender, we want to see how many of the customers were male and how many were female. Let me open the supermarket data set. All these data sets have been uploaded on Canvas. Supermarket transaction. Okay. So we have this data set. We want to see how we can report the categorical variable, like gender. We have only 2 categories for this variable, either male or female. We want to count the number of male and female. You know that the only way to report categorical variables are just to to count or report the percentage. So we want to count the gender, male or female. Okay. So we can use the functions in Excel. Let me go back. In the column D, we have to count the number of male and female from row 2 through row 14060. Okay. With Control End and Control Home, you can go to the start and end of the file. Control Home and Control M. So now suppose we want to count the number of male in column D. We can use this function, equals count if. This function takes two arguments. First argument is the range of data, and the second argument is the criterion. So we want to count the number of male in column D. D2 through D140, 60. This is our range and our criteria. We want to count the number of male, or M, in column D. Double quotation M. Out of over 1,000 records, we have 6,889 male. And again, we can use the same formula for this one, for female, that equals, we want to count if the range, again, is the same, D2 colon D140, 60. This is our data range, and our criterion is female, F. To make sure these numbers are correct, we can sum them to calculate the total. Equals summation of these two cells to see if it is equal to the maximum number or not. 140, 59. Control End, we go to the last one. Yes. We have 14,059 people or customers. Out of that number, about 6,000 are male and 7,000 are female. Questions so far? No question? Okay. Let's move on. This way we can report categorical variables. And you can also count the percentage. For example, to report the percentage, this is the count and percentage. You can divide it by the total. That equals S4 divided by the total. S6. Here's the percentage for this one, and again S5 divided by S6. Here's the percentage. Again, the total, the summation. We take the summation to make sure we have correct results. Yes, that's correct. And we can show them on a bar chart. we have two categories, male and female. We can go to insert, recommended chart. The best method to represent two categories is the bar chart. That's how we work with uh, categorical data. And there are some other built-in tools like stat tools. You can install it through that DTS suite that they uploaded in Canvas. When you get the textbook, you get the keyword to install and activate the stat tools. So please make sure to install the stat tools. That makes your job easier. So we can use this column and we don't be with the stat tools. We don't need to type those functions and etc. For example, we can go to the summary statistic, summary data. Oh, sorry. First, I have to define my data set. Here we need to define our data range. Let me do this another way. Control Shift Ent. Okay, here's our data range. First, we define our data range, and then we can go to the summary statistic, one variable, summary. For example, we select gender, and we get all the reports regarding mean, variance, standard deviation, and etc. It makes no sense to get these reports for this variable. With categorical variable, we just need the count and sum of those variables. The rest measures are just applied to the numerical variable. So we just want to get the count and summation of the categories. Okay, it looks like the stat tool cannot work with categorical data. So we will just use the stat tools with numerical data. With numerical data, we can just use this count if version, count if function. So we use count if, and we can use different type of diagram to report a categorical variable. Okay. So now let's go to the numerical variable. Okay. We can report our numerical variables through numerical summary measures, charts, and tables. Okay. For example, when we want to see the salaries of the baseball players, we want to know what is the typical salary, how spread out are the salaries, what are the extreme values in that data set, and we want to know about skewness and etc. So if we want to summarize this table with numerical variables, we are interested in these parameters. Measure of central tendency, like mean, median, mode. We also want to know how spread out is our data or variability. We use variance and a standard deviation. And also we want to know the shape of our data or the distribution of our shape. So typical salary or typical value is all about measuring the central tendency or measuring the average or mean or median. Okay, spread out the salary is about the variance of the data extreme values or maximum minimum, and also the shape of the distribution. We want to see whether our data or its distribution is symmetric or asymmetric. So for example, for a salary variable, we want to measure central tendency, minimum maximum percentile, measure of variability, empirical rules, and measure of shape, and also some other numerical variable. Now let's go to this baseball salary to see how we can work with numerical data. Let me close this Excel sheet and go to baseball dataset, baseball salaries. Okay, so this dataset contains the salaries of famous baseball players. We want to see who makes the most salary, who makes the least salary, what is the typical salary in this data set, and what is the variance of this data set, and etc. So we want to measure different kind of parameters for this variable salary. And as you know, salary is a numerical ratio variable. We want to calculate measure of central tendency. It includes mean, okay. Is everybody following me? Start, what is this? Okay. Measure of central tendency, we want to calculate mean, mode, and median. Okay, so what is mean? Mean is the average of all values. In order to calculate the mean, we need to sum all of the values, its summation with this sigma symbol. It means we want to sum all the values from number 1 to observation n, and then divide it by n, number of observation. Summation of all the values from observation 1 to n and divided by number of observation. This is called mean. If we apply to a sample of data, it will be called sample mean, and we use X bar to represent it. And for population, we use this symbol, mu, which is a kind of Greek symbol. And in Excel, we use average function. For median, which is the middle observation, when we sort data from lowest to smallest to the largest, we use median function in Excel. So if the number of observation is odd, median is literally the middle observation, and if the number of observation is even, the median is defined as the average of two middle observation. Okay, is there a way for students to get the stat tool add-ins? It costs money to download. Actually, if you get the textbook, you will be given access to those kind of keys to use this for free. But let me contact those people in Palisade Corporation. They're in Palisade company to see if we can get free kind of license for our class. But I encourage everyone to try it and then contact their Palisade company, contact their customer service to see if you can get free access or not. I will follow up with them and let you know the results. Does that answer your question? Okay, okay. So now, median. So for average or mean, we take the summation of all the values divided by number of variables, and we take the average. For median, we sort the data from smallest to the largest, and the middle observation is going to be our median. The problem is that if there are odd number of values, the median is going to be exactly the middle observation. If the number of observations is even, we have to take the average of two middle observations. So in Excel, we use median function. And mode is the value that appears most often, kind of most often salary. And we use mode function for that. So now, let's see how we can calculate these values. Measure of central tendency, mean, median, and mode. First, let's see what is the range of our data. It starts from D2, and then we take Control End to go to the end of the data set. The last record is 869. Here is the 869. D2 through D869. It equals average D2 through D869. Here's the average salary in this data set, $4 million. For mode, which is the value that occurs most often in this data set, we use the mode function. Again, we use the same range, D2 colon D I missed 2 here. D869 multiple. This result shows that multiple people receives this salary, $500,000, and median, which is the middle observation, that equals median. We need to again define the range D2 through D869. Median value is 1,650,000. Question: there is a big difference between mean and median. What could be the reason for this big difference? Mean is the average of all values, median is the middle observation. What could be a reason for this big difference between mean and median? Shouldn't they be the same? Let me open your microphones. Unmute all. Now please share your thoughts. Any answers? I'm waiting for your answers. Is everybody with me? Okay.
I just can't hear anything.
We got civilians behind the barricade. Stay behind them. I will deal with you.
The question is that all these three measures, they report, they give some information about the average or about the center of this variable. Why is there such big difference between mean and median? Why mean is 3 million more than median?
There's some people that make like millions, and like 21 million, and while there's a lot of people that make like 100,000.
I didn't get that. Please say that again.
There's so many people that make like 24 million and above, while there's a lot of people that also make like 500,000 or
Yeah,
middle.
exactly.
All.
Exactly. There are some extreme values. There are some big values in that data set. The number of people who make above $1 million is bigger than the number of people who make less than $1 million. That's why there is big difference between mean and median. Because some people, they're top players, top baseball players, they make multi-million dollars. And in a statistic or data analytics, we say that our data is skewed to the right, or it is positively skewed. There is a skewness in our variable, okay? This difference shows that our data is not symmetric, or we can say it is skewed. For the measure of variability, we have range, interquartile range, variance, standard deviation, mean, and etc. For the measure of shape, we have skewness and kurtosis. Now let's calculate the skewness to see if it is positively or negatively skewed. Skewness, again, D2 through D469. Yes, it is. If it was 0, it would be symmetrical. Now we have positive value for a skewness. It means our information is skewed to the right. Let me show you the skewness in stat tools. One variable. Let's use histogram. First, we need to define our range dataset. New data range. Control Shift Ent. Here's our data range. And now stat tools can identify this information and variables. Now we go to the summary graph, histogram. We want to see the distribution of the salary to see if it is skewed to the right or not. Do you guys see? This shape shows the skewness to the right. It starts from large numbers, frequency large, and it goes down to these numbers. So this picture shows that it is skewed to the right. Exactly the same result that we got from this function, skewness to the right. Okay, so minimum, maximum, and percentile, these are used to calculate the extreme values in our data set. Range, to measure the variability, we can define the range, which is the difference between maximum and minimum range. Variance is the average of the squared deviation from the mean. And interquartile range is the difference between third quartile minus first quartile range. This formula is used to calculate sigma squared to calculate the standard the variance for the sample, and this one is for the population. And we can also use var.s for sample, var.p for variance of the population. A standard deviation is the square root of the variance, and I'm going to go to the skewness. Skewness occurs when there is a lack of symmetry. When our distribution or our diagram is not symmetric, we say that it is skewed. Our diagram or distribution is skewed. It can be either skewed to the right, like what we just saw with our distribution, or it can be skewed to the left, negatively skewed. Okay. So because of this skewness, there is a big difference between mean and median. So these are regarding the central tendency variance reports information regarding the variance or variability of our data set. And skewness is used to see if the shape of the distribution is symmetric or not. Any questions? All right. Let me show you how we can see the summary measures regarding a single variable. In the stat tools, we go to the summary statistic, one variable, summary. We select salary. We can get all these reports, mean, variance, standard deviation, kurtosis, first quartile, and etc. Okay. Again, mean is $4 million. Variance is this one. Standard deviation is the square root of variance. These two tells us about how spread out our data is. Skewness, which is positive. Median, mode, and you get the result for everything that we need for the data analysis.